Okay, density is a measure of how closely the particles of a substance are packed together. So the density of a substance is its mass per unit volume. So the formula for density is D equals M over V. Let's try to solve this question on the density. Here it says a 50 gram rock has a volume of 8.5 milliliters. What is the density of the rock? So we know that the density is equal to mass over volume. Okay, so we write that. Then we replace M with mass we are given, which is 50 grams over the 8.5 milliliters. And then when we divide, we are going to find the answer. All right, so 50 divided by 8.5, that is 5.88. Then you just get the grams per milliliters, and that's the answer. Okay, let's try to check if you are given a question where you need to find its mass instead of density. Let's check this question. Where the question says a metal bar has a density of 7.9 milligrams. If the volume of the bar is 500 milliliters, what is the mass in kg? Okay, so density is equal to mass over volume, but this time around we're asked to find the mass. Okay, so when you are told to find the mass, you need to multiply density and volume for you to get the formula for mass. So mass is equal to density multiplied by the volume. So the mass is going to be 7.9 grams over the milliliters multiplied by 500 milliliters. Okay, then when you cancel the milliliters, you're going to only remain with a gram there as a unit. Then you're going to say 7.9 multiplied by 500, and the answer you're going to get is 3950 grams. Okay, so we found the answer. So for you to find the answer in the kgs, you just divide the answer you found in grams divided by 1000. Then the answer you get to be in kgs. Okay. Now let's look at the density of a liquid. The first step is you need to find the mass of an empty cylinder you are using. Number two, you need to pour the unknown liquid that you want to find its density. Then find the mass of the cylinder plus the liquid that you've put in the cylinder. All right. Okay, then you need to subtract the mass of the cylinder from the mass of the cylinder plus the liquid, so that you're able to find the mass of the liquid. Okay, so when you find the mass of the liquid, okay, then you need to measure the volume of that liquid. Once you measure the volume of that liquid, divide the volume into the mass of the liquid. There you go, you have the density. Now let us look at this example on how we calculate density of a liquid. So put the beaker on the scale, and you can see that is the 50.0 grams. Okay, after knowing that, you record that, then you put the liquid into the beaker, and you see the grams are increasing there. Okay, so we find the mass of the beaker and the liquid, which is 99.9 grams. Then we need to subtract 99.9 grams minus 50. The mass of the empty was 50.9 grams. The mass of the beaker was 99.9 grams. So we need to find the mass of the liquid by subtracting 50 from 99.9, and the answer is 49.9 grams. Now let's go and find volume. You can see the volume there is 40, 50, 68. That is 40, that's 50. You see where the liquid is? 50 is the 50 cubic centimeters. Then you divide 49.9 over 50 milliliters, okay, which is 0.998 grams per milliliters, which is also same as when we 1 gram per milliliter when we round off. Okay, so let's try to see how we can be able to calculate density of an irregular solid. Okay, so this time around we are going to use two methods of finding the density of irregular solids.
This experiment is to determine the density of an irregular solid, in this case a pebble, and the apparatus that I have: one, an electronic balance for measurement of mass, a measuring cylinder, it will help me in measuring the volume, a Eureka can, it's also known as an overflow can, it will help me in measuring volume together with the measuring cylinder, and of course I have water, which is going to help me use the displacement method for determination of volume. You might notice that unlike the case where I have a big enough measuring cylinder to determine the volume directly by displacing the liquid, in this case the solid does not fit in the measuring cylinder. That is the reason why I'm going to use an overflow can. First, I'm going to determine the mass of my pebble by placing it carefully on the pan of an electronic balance. It gives me 40.14 grams, and after that I will want to determine its volume, and what I will do is pour water into the Eureka can, into the overflow can, until the water overflows from the spout. This spout is the one that will determine that I put in enough water. So if you have a quick look, there is that overflow of water. Once it overflows and the overflowing stops, then I will now tie my solid using a thin string, and next I'm going to trap any water that will be displaced in using a measuring cylinder. So I'll have my measuring cylinder here, I'll place it right there, and then immerse my solid fully in the Eureka can until all the water that overflows stops overflowing, and the volume of water displaced should be equal to the volume of the solid. In this case, when I take my reading, taking care of parallax errors, I'm having my eye level with the reading being taken, and I'm keeping my eye at the bottom end of the meniscus. What I have is 10, 15, 16 cubic centimeters. Of course, I didn't allow all the water to overflow, but that gives a quick idea of what volume we are dealing with. So after this, I will go ahead and say the mass I obtained there divided by the volume of the liquid displaced will give me the density. And my answer, of course, in grams per cubic centimeter. If I wish to change it to kilograms per cubic meter, I will multiply that answer by 1000.
So that is exactly how you find the density of an irregular solid. Now, let us look at what relative density is. What is relative density? You need to understand here is, as long as the mass of equal volume of water and the liquid whose density is to be determined are known, then the density of the liquid can be determined as follows. You can say the relative density is equal to the mass of the liquid over the mass of the equal volume of water. So this is exactly what you can do when you want to find the relative density. For example,
look at the word relative. What does it tell you? It tells us that we are looking at the density of something relative to the density of something. We are comparing the density of one thing to the density of another. That's all. But the question is, relative to what? It's most typically the density of water. Yes, we look at the density of an object relative to the density of water. How do we define the relative density of a substance? It equals the ratio of its density to that of water. Yes, density of the substance over the density of water. Can you tell me the unit of relative density? Look at the right-hand side and tell me the unit. As it is a ratio of similar quantities, relative density will have no units. The units from the numerator and denominator cancel each other out. The density of water is 1000 kilograms per meter cubed, and the density of silver is 10,500 kilograms per meter cubed. So can you tell me the relative density of silver? It's easy. Just refer to this formula and try answering it. It will equal the density of silver over the density of water. Substituting the values here, we get the answer as 10.5. That's the relative density of silver. What does the relative density tell us though? What can we understand from this? First, it tells us that silver is a lot more dense than water under the given conditions. Approximately 10.5 times denser. But that's pretty obvious given the numbers. This tells us another important thing. It tells us whether the object will float or sink in water. In simple terms, a substance will sink if it's denser than the liquid it's placed in. And it will float if it's less dense than the liquid it's placed in. How can we say this mathematically? If the relative density of a substance is greater than 1, then it will sink, and if it's lesser than 1, it will float. As the relative density of silver is 10.5, which is greater than 1, it will sink in water. But if we take the example of ice, its density is approximately 934 kilograms per meter cubed. So its relative density will be 0.934. As its relative density is lesser than 1, it will float in water. We can understand this with a simple diagram. Take 4 beakers filled with water. In the first one, drop a substance with a relative density of 0.1. You'll see that it floats like this. In the second one, drop a substance with relative density of 0.4 and you'll see that it floats like this. More of it is inside the water. And if it's 0.9, even more of it will be inside the water. But it will still float. And if it's greater than 1, say 1.2 or 1.3, then it will sink. Okay, here's one last question for you. Can the relative density of an object be 0? The answer is no, it can't be 0. Because if the relative density is 0, it will mean that the density of the substance is 0, which in turn will mean that the mass of the substance is 0. For any given substance, its mass in a given volume cannot be 0.
What are some of the uses of density? How is density helpful? Chemicals in industries can be separated by using their different densities. You can separate them by using their different densities because each chemical has its own density. So you can separate using the density. Okay, so you are welcome to this our channel. All right, so if you've not yet subscribed, please subscribe so that you're able to be notified whenever we upload any helpful video. Don't forget also to share this video with all those that are writing their grade 12 exams either this year, next year, or another year. All right, this is dedicated to all those students that are writing their grade 12 exams, the GCEs, and even others who just want to use this for education purposes.